Today, we are talking about a major breakthrough from Google. And honestly, it could change pretty much everything we know about computing. So get this. Imagine a computer that can solve a problem in minutes, a problem that would take our absolute fastest supercomputers billions of years to crack. Well, that's the kind of power we're talking about with a new chip called Willow, and we're going to break down exactly how it works.
So let's just start with this really mind-bending question. What if a computer could figure something out in the time it takes you to, drink a cup of coffee, while the most powerful supercomputer on the planet would need longer than the entire age of the universe to do the same thing? And I'm not kidding, that's 13.8 billion years. This isn't some sci-fi movie plot, it's the reality of quantum computing, and we are right on the verge of a completely new era.
And the key to this incredible new world? Well, it has a name, Willow. It's not a person. Nope, it's a revolutionary quantum chip that is literally rewriting the rules of what's possible. And it is the heart and soul of this incredible breakthrough from Google.
Okay, let's dive right in. Willow is the result of more than a decade of really intensive research over at Google's Quantum AI lab. And you gotta understand, this isn't just another chip. It represents a major milestone in the whole quest to build a practical, large-scale quantum computer. One that can solve some of the world's most difficult problems.
Now, Willow didn't just pop up out of nowhere. It's actually the latest in a whole line of groundbreaking chips from Google. You might even remember Sycamore back in 2019. That was the chip that achieved what they called quantum supremacy by doing a calculation that was, for all intents and purposes, impossible for a normal computer. Well, Willow takes that achievement and just takes a giant leap forward.
So what is it that makes Willow so special? Well, it's all about cracking a problem that's been bugging scientists for 30 years. It's been the Achilles heel of quantum computing, the problem of errors. And this, right here, is where the real magic of Willow starts.
Okay, so the heart of any quantum computer is the qubit. Now, unlike a regular computer bit, which is just a 0 or a 1, a qubit can be both at the same time. It's this weird state called superposition, and it's what gives these computers their insane power. But it's also what makes them so fragile. Think of it like a soap bubble. It's beautiful, it's complex, but it is incredibly delicate. The tiniest disturbance, what scientists call noise, can just pop it and destroy all the information inside.
Now this is where it gets really interesting, because this slide basically flips a fundamental problem of quantum computing on its head. For decades, the rule was simple. The more qubits you add, the more errors you get. It was this frustrating catch-22. But Willow completely changes the game. For the first time ever, as the system gets bigger, it gets better. The error rate actually goes down. This is, and I'm not exaggerating, a massive breakthrough.
And here's how they actually proved it. They started small, with a little 3x3 grid of qubits, and they measured the errors. Then, they scaled it up to a 5x5 grid. And guess what? The error rate was cut in half. So they did it again, with a 7x7 grid, and the error rate dropped even more. This is basically the holy grail of quantum error correction. It's a goal the entire field has been chasing for nearly 30 years. And with Willow, Google has finally done it.
So Willow conquered the error problem. That is a huge step. But what does that actually mean when it comes to raw computing power? Well, let's take a look at Willow's second major achievement. A calculation so fast, it is almost impossible to wrap your head around. That number you see on the screen, that's 10 septillion. That's a 1 with 25 zeros after it. I mean, just to put that into perspective, if you were to count to 1 billion, it would take you about 30 years. Willow performed a calculation in under 5 minutes that would take the world's fastest supercomputer 10 septillion years to finish. It is just a completely mind-boggling leap in power.
And this chart, wow, it really drives home just how incredible the speed of Willow is. 5 minutes versus a timescale that makes the age of the entire universe look tiny. I mean, the gap is almost incomprehensible. And what's even crazier? This is just the beginning. Quantum processors are getting better at what's called a double exponential rate, which basically means the next jump forward could be even more dramatic.
This jump in power is so profound, it's actually forcing scientists to rethink the nature of reality itself. Hartmut Neven, the founder of Google's Quantum AI lab, he actually suggested that the only way to explain this kind of power is to imagine the calculation happening across multiple parallel universes at the same time. It's a wild idea, for sure, but it really speaks to the incredible potential of this technology to unlock the secrets of the cosmos.
Okay, so parallel universes, unimaginable speed. It is really easy to get lost in the hype. But let's pull it back down to Earth for a second.
What does all of this mean for us, right here, right now? How close are we to actually seeing any practical applications of this incredible technology?
And that brings us to a really important part of our story, the reality check. Because to truly appreciate just how significant Willow is, we also have to understand its limitations. The road to a practical, useful quantum computer is still a long one. It's a challenging one, but Willow has finally given us a clear path forward.
So let's take a quick look under the hood. Willow has 105 qubits, which is more than double its predecessor, and its coherence time, that's basically the amount of time a qubit can hold its quantum state, keeping that soap bubble from popping, that has been improved by a factor of 5. These are huge engineering achievements for sure, but they also kind of highlight the challenges that are still ahead.
So here's the crucial point. Willow is a massive step forward, but it is not the final destination. The error rates, while they are record-breakingly low, are still thousands of times too high for the really complex stuff like designing new drugs or creating revolutionary new materials. And so far, the big win has been in preserving the quantum information, not yet in doing complex calculations at that same super low error rate. So for now, Willow is a research prototype. It's a brilliant glimpse of the future, but it's not yet a practical tool. So, where do we go from here? What's next for Willow and for the entire world of quantum computing? And really, when can we expect to see this incredible power start to show up in our daily lives?
All right, let's talk about the elephant in the room, encryption. There's always this fear that quantum computers will just break all the codes that protect our data online. But Google's been really clear about this. They say that is still at least a decade away. Building a quantum computer powerful enough and stable enough to break modern encryption is an incredibly complex challenge. So for now, your online data is safe.
The key takeaway from all of this is that Willow is a monumental milestone. It is the proof of concept. It proves that a fault-tolerant quantum computer isn't just a dream, it's an achievable reality. Think of it like the Wright brothers' first flight at Kitty Hawk. We're still a long way from commercial air travel, but we've finally proven that we can fly. Willow has completely changed the conversation from if to when. The proof that a useful quantum computer is possible, it's here. And now, the global race is on to actually build it. So the question is no longer whether we'll have a quantum future, but what are we going to do with it when it finally arrives? What problems will we solve? What new worlds will we discover? The possibilities are as limitless as the quantum realm itself.